Mount Vesuvius, a large volcano in southern Italy, is most famous for its eruption in 79 AD, one of the deadliest volcanic events in history. During the eruption, Mount Vesuvius sent a huge cloud of hot ash and gases up to 21 miles into the sky. The volcano released 1.5 million tons of molten rock, ash, and pumice every second. And the total energy released was 100,000 times more than the atomic bombs dropped on Hiroshima and Nagasaki. The eruption created what is now known as the Vesuvian eruption, with columns of gas and ash reaching high into the atmosphere. The eruption also caused pyroclastic flows. The eruption destroyed several Roman towns, with Pompeii and Herculaneum being the most well known. These towns were buried under layers of ash and rock. Excavations have since uncovered much about the lives of the people who live there. These sites are now part of the Vesuvius National Park and a UNESCO World Heritage Site. Around 20,000 people lived in the destroyed towns. The remains of over 1,500 people have been found in Pompeii and Herculaneum. The total number of deaths from the eruption is still unknown. Smaller earthquakes occurred in the 4 days before the 79 AD eruption, but they weren't seen as serious. The people who lived near Mount Vesuvius were used to these minor tremors, and they didn't think the earthquakes were a warning of a major eruption. The eruption lasted for 2 days. The first day wasn't too noticeable in the nearby town of Misenum, where Pliny the Younger lived. However, around 1 p.m. on the first day, the volcano erupted violently, sending ash and pumice into the air, which began to fall over the surrounding area. People in the area started to try to escape. During the night or early the next morning, pyroclastic flows began. These hot, fast-moving flows of gas and debris destroyed everything in their path and killed many people by suffocation or burning. There were also additional tremors and a small tsunami in the Bay of Naples. By the evening of the second day, the eruption had stopped affecting Misenum, and the only thing left was a hazy atmosphere. Pliny the Younger, who was 17 years old at the time, was staying in Misenum, about 18 miles from the volcano. Pliny the Elder, his uncle, was in charge of the Roman fleet at Misenum and decided to investigate the eruption. He set out with a rescue fleet to help people near the volcano, but Pliny the Younger chose to stay behind. Pliny the Younger described the eruption's cloud, saying it looked like a pine tree with a tall trunk that spread out into branches at the top. The cloud changed color as it mixed with ash and gases. Pliny the Elder, as the commander of the fleet, decided to investigate the eruption closely. A message from his friend Rectina, who lived near the volcano, asked for help because she could only escape by sea. Pliny the Elder sent ships to help, but continued his mission. When he reached the area near Stabii, he saw the volcano was burning in several places. He and his crew decided to spend the night there. There was an earthquake during the night, and they had to leave the building. They went to the fields to protect themselves from falling rocks. The next day, the ship couldn't leave because the wind was too strong. Pliny the Elder sat down, unable to get up, and it's likely that he died there, possibly from the poisonous gases. His companions eventually escaped by land. In his letters, Pliny the Younger suggested that his uncle died because the fumes from the volcano affected his lungs. However, it's unclear exactly how he died, as other people nearby weren't affected. Next on our list is in Krakatoa, Indonesia. Beginning on May 20th and culminating on August 27th, the eruption caused the collapse of over 70% of the island into a massive caldera. This extraordinary geological event unleashed destruction on a scale rarely seen, marking it as one of the deadliest volcanic disasters ever recorded. The explosions that occurred during the climax were so intense that the sound of the largest one, at 10:02 a.m., was heard thousands of miles away, reaching places as distant as Australia and the island of Rodriguez in the Indian Ocean. This explosion is considered the loudest sound in recorded history, and the force of the eruption created a pressure wave that circled the globe multiple times. The impact on Krakatoa's eruption was catastrophic, claiming the lives of at least 36,417 people. Most of these fatalities were caused by enormous tsunamis triggered by the explosions. Waves reached astonishing heights, up to 46 meters in some areas, wiping out entire villages and sweeping away vegetation and settlements. Many survivors who were anchored near Telobetong recalled witnessing the horror of the eruption unfold before their eyes. They watched the wave advancing so rapidly that the ship barely managed to ride over it. The crew watched in shock as they saw the wave consume the town completely, leaving nothing but open water. On land, the devastation was devastating. A farm worker near Merak recalled hearing a thunderous sound before seeing a massive black wave approaching. People fled for higher ground, but the wave moved too quickly for many to escape. In a desperate struggle, those climbing steep slopes fought to survive, clinging to one another as the waters swept them away. Globally, the eruption had profound effects. Ash and gases injected into the atmosphere disrupt weather patterns, creating stunning sunsets. It even temporarily cooled the Earth's surface. Scientists estimate that the eruption released energy equivalent to 200 megatons of TNT, several times more powerful than the most destructive nuclear weapons ever tested. Onward to Mount St. Helens in 1980, a dramatic eruption that changed the landscape of Washington state. On March 27, 1980, Mount St. Helens in Skamania County, Washington, began a period of intense volcanic activity that ended in a catastrophic eruption. This event, marked by a volcanic explosivity index of 5, was the most disastrous volcanic eruption in U.S. history. The lead up to the eruption included 2 months of escalating seismic activity and steam venting episodes. Magma injected at shallow depths caused the volcano's north slope to develop a large bulge and a network of fractures. On May 18th, a magnitude 5.1 earthquake triggered a massive sector collapse. This was the largest subaerial landslide ever recorded. The eruption generated an ash column that reached an altitude of 15 miles, dispersing ash across 11 US states and parts of Canada. Simultaneously, melting snow, ice, and glaciers produce lahars that travel nearly 50 miles to the Columbia River. The initial eruption released energy equivalent to 26 megatons of TNT and was followed by less destructive eruption throughout 1980. The disaster claimed 57 lives, including notable figures like innkeeper Harry R. Truman, photographers Reed Blackburn and Robert Landsberg, and volcanologist David A. Johnson. Hundreds of square miles of forest and terrain were obliterated. Over $1 billion in damages were incurred, and thousands of animals perished. Mount St. Helens itself was transformed, its summit replaced by a crater on the north side. After the eruption, Burlington Northern Railroad, which owned the summit at the time, donated the land to the U.S. Forest Service. The area was later designated as the Mount St. Helens National Volcanic Monument to preserve its unique geological and ecological features. May is now recognized as Volcano Awareness Month in Washington, commemorating the lives lost and promoting awareness of volcanic hazards. Our next stop is Eyjafjallajökull in 2010, which disrupted air travel across Europe. What did it teach us about the interconnectedness of modern society? Imagine the skies of Europe suddenly empty. No planes, no flights, just silence. Between March and June 2010, the Eyjafjallajökull volcano in Iceland erupted with such force that it paralyzed air travel across Western Europe, disrupting millions of lives. Over 6 intense days in April, the world watched as nature's power grounded over 10 million travelers and halted aviation in 20 countries. The chaos wasn't immediate. It began quietly in late 2009 with small tremors deep beneath the earth. By March 20, 2010, the volcano had warmed up, producing a modest eruption. But the real spectacle began on April 14th, when Eyjafjallajökull roared into its second explosive phase. A vast ash cloud shot about 5 miles into the sky, darkening northern Europe and creating the worst air travel disruptions since World War II. The volcanic power behind it was unbelievable. An eruption rated 4 out of 5 on the Volcanic Explosivity Index, ejecting 250 million cubic meters of ash and rock. Planes were grounded, businesses lost billions, and stranded travelers scrambled to find shelter. Meanwhile, Iceland dealt with its own challenges. Lava and ash threatened rivers, melting glaciers and sparking flash floods. Local families were evacuated as roads closed and reopened in a tense dance with nature's unpredictable fury. The eruption produced new geological marvels, including a rare pseudocrater formed during a dramatic steam explosion, something never observed before. By June, the volcanic activity slowed down, though tremors were there, keeping Icelandic scientists in full anticipation of what's next. Finally, in October 2010, it was officially declared dormant. So, what did the world learn from this event? Eyjafjallajökull showed us just how interconnected modern society is. A single eruption on a small island caused ripple effects worldwide, grounding planes, disrupting supply chains, and separating families. It reminded us how much we depend on fragile systems like global air travel, and how a natural disaster, even thousands of miles away, can bring them to a standstill. Next, let's shift our focus to Mount Tambora, another defining volcanic eruption in history. In 1815, Mount Tambora, a towering volcano on Sumbawa Island in present-day Indonesia, erupted with such ferocity that it remains unmatched to this day. This eruption, classified as a Volcanic Explosivity Index 7 event, released 37 to 45 cubic kilometers of dense rock equivalent material into the atmosphere. So, what made this event so devastating? For starters, this completely destroyed the lush vegetation on Sumbawa Island, transforming it into a barren wasteland. Trees were uprooted, coated with pumice and ash, and carried into the sea, forming massive rafts as large as 5 kilometers across. British ships sailing 3,600 kilometers west of Tambora encountered these floating remnants months later. It is estimated that tens of thousands perished directly from pyroclastic flows and ashfall. Even more succumbed to starvation and disease caused by the destruction of crops and contamination of water sources. On Sumbawa alone, 18,000 people reportedly died from hunger and disease, and neighboring Lombok saw 10,000 fatalities. Some sources place the total death toll at around 88,000. The eruption's reach extended far beyond Southeast Asia. Tambora's massive eruption column pierced the stratosphere, spreading fine ash particles across the globe. These particles reflected sunlight, significantly cooling Earth's climate. This led to the infamous Year Without a Summer in 1816, where global temperatures dropped by an average of 0.53 degrees Celsius, which is about 0.95 degrees Fahrenheit. Today, scientists study Tambora to better understand the links between volcanic activity and climate change. Our next stop is Mount Pinatubo. The 1991 eruption of Mount Pinatubo in the Philippines was one of the most powerful volcanic eruptions of the 20th century, second only to the 1912 Novarupta eruption in Alaska. The eruption began in April with small explosions from a fissure on the volcano's north side. Scientists set up seismographs to monitor the volcano, detecting a rise in seismic activity as the days went on. By late May, the frequency of earthquakes beneath the mountain increased, signaling growing volcanic activity. On June 6th, a series of shallow earthquakes accompanied by swelling on the volcano's upper east flank. This eventually led to the formation of a small lava dome. Then, on June 12th, the first major eruption occurred, sending a massive ash cloud 12 miles into the sky. More explosions followed overnight and into the morning of June 13th. Seismic activity continued to intensify, and on June 15th, the volcano erupted explosively, shooting an ash cloud 25 miles into the atmosphere. The eruption covered the surrounding countryside with ash and pumice, while powerful pyroclastic flows raced down the volcano's slopes. It filled deep valleys with volcanic deposits up to 200 meters thick. The ash cloud from the eruption was so vast that it circled the globe, reaching as far as the Indian Ocean. Commercial flights unknowingly flew through the ash cloud, causing about $100 million in damage to at least 16 planes. The eruption destroyed nearly every bridge within 19 miles of Mount Pinatubo, and several towns were partially buried in mud. The collapse of roofs under heavy, wet ash killed at least 840 people and injured many more. The eruption's impact didn't stop there. Over the next few years, heavy rains caused the volcanic ash to mix with water, creating more lahars that damaged bridges, roads, irrigation systems, and farmland. These secondary mud flows affected many more people over a much longer period than the eruption itself. Our next visit is to the Alaska Peninsula. Novarupta, located in Katmai National Park and Preserve, erupted in 1912. On June 6th, Novarupta unleashed a violent eruption that lasted for 60 hours, releasing an unimaginable amount of magma and ash. In fact, it expelled between 3.1 and 3.6 cubic miles of ash, and 30 times more than the 1980 eruption of Mount St. Helens. Rated ultra-Plinian, this eruption is considered one of the most explosive in recorded history. The eruption created a massive 2,000-foot deep caldera and released over 4.1 cubic miles of airfall tuff and 2.6 cubic miles of pyroclastic flow. To put it into perspective, only a few other eruptions, like the Mount Pinatubo eruption we discussed before, have been similarly massive. The blast also caused the collapse of Mount Katmai's summit, creating a funnel-shaped vent and eventually forming the Novarupta lava dome, which stands 295 feet tall. The ashfall was so dense that it caused near-total darkness, contaminating drinking water and destroying food sources. Yet, thanks to traditional surviving knowledge, Alaska natives managed to endure the event. Many of the villages most affected by the ash were abandoned, and their people relocated. One of the most captivating features created by the eruption is the Valley of 10,000 Smokes. Pyroclastic flows formed this vast valley, and for 15 years after the eruption, fumaroles, steaming vents in the ground, continued to emit hot gases. The valley's colorful ash deposits have made it an important site for scientists, and botanist Robert F. Griggs, who explored the area in 1916, famously named it the Valley of 10,000 Smokes. For the last one on our list, we're at Laki, Iceland. The 1783 to 1784 Laki eruption in Iceland, also known as the Skaftar Fires, stands as one of the most significant volcanic events in recorded history, even though it wasn't a massive explosion like the infamous eruptions of Tambora or Krakatoa. Instead, it was an extended series of volcanic events lasting for 8 months, during which the eruption expelled a staggering 14.7 cubic kilometers of basaltic lava from 140 vents. The eruption's impact, however, extended far beyond Iceland's borders, with consequences that would ripple through the northern hemisphere for years to come. The scale of the eruption is mind-boggling. To help visualize, imagine that the volume of lava could fill the entire city of Boston to a depth of 63 meters with solid basalt. Interestingly, this eruption didn't come out of nowhere. Before it began in June 1783, a series of earthquakes were felt in the surrounding regions, providing some early warning signs. Once the eruption began, it followed a regular pattern: earthquakes, fissure openings, explosive eruptions, and lava flows. The eruption's explosive phases generated ash clouds, and the lava flows were so fast and continuous that some eruptions reached eruption rates of 8,600 cubic meters per second. The eruption contributed to one of the most devastating environmental events in history, the Laki haze, which resulted in widespread famine and health crisis across Europe and North America. The sulfur dioxide from the eruption formed sulfuric acid aerosols in the atmosphere, which caused a dramatic cooling effect, leading to crop failures, food shortages, and significant loss of life. In Iceland itself, the effects were devastating, with an estimated quarter of the population dying from hunger, disease, or the effects of the toxic gases. The eruption of Laki is still a topic of research and debate, particularly regarding its direct effects on global climate. Many scientists continue to study how these types of volcanic events influence the Earth's climate over the long term, especially in the light of the devastation caused by Laki. Which of these shocked you the most? Let us know your thoughts in the comments below. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating content.